So today we're going to talk about areas of circles and the sectors. So area of a circle formula, just remember that's pi r squared, and area of a sector of a circle. So again, that's kind of like a piece of pie that you're cutting out of a circle. That's what a sector is. So that is going to be the measure of the arc over 360 and then times the area of the circle. So we're going to look at an example here. So if we're going to find the area of the sector GPH. So the part that I'm looking at is this piece here. So I want to find the area of that. So again, I'm going to take the arc measure, which is 72 over 360, and then times pi times the radius squared. So they give me that the radius is 15 squared. So that's going to become 1/5 times 225 pi. And then if I reduce that, 225 divided by 5 is 45 pi. I'm just going to, again, leave that in terms of pi there. The next type of problem we're going to have is the area of a segment. So our segment's going to be this part right here, part of that circle there. So to find that, we're going to take the area of the sector. We're going to subtract out the area of the triangle. And then we're going to get the area of the segment. So first, we're going to find the area of the sector. So this part here is what we're actually trying to find. So you want to color that part in. So the full sector here is ACB. So I'm going to have 60, my arc measure, over 360, and then times pi times my radius squared, and the radius is 18. So when I simplify that out, I'm going to get 54 pi. So then the next thing I need to do is find the area of the triangle. So the triangle I have is an equilateral triangle. So if I cut it in half, I've got 30 here, and my side lengths are 18. So if I cut them in half, this will be 9. This is 18. So I'm going to just pull out this small triangle here. So I've got 9. If this is 30, my long side should be 9 square root of 3. So for the area, if I want my whole base is 18. So I'm going to do 18 times 9 square root of 3 divided by 2 to get the area for the triangle. So 18 times 9 divided by 2, that gives me 81 square root of 3 for the area of the triangle. So then to get the area of the segment, I'm going to take my area of the sector, which was 54 pi, minus the area of the triangle, which is 81 square root of 3. So that will equal the area of that small segment there. Again, you can just leave that as it is. So part of it's in terms of pi, the other part is in the square root, so we can't combine those unless it wants us to round. And then the last example we're going to look at is just a working backwards problem. So this says find the radius. So we need to find the radius of the circle. So this is what we're looking for here. And so what we have to do is figure out which formula we're going to use based on what we're given. So we're given this arc length here is 42.6. So I'm going to use the arc length formula, which is my angle over 360 times pi times 2r. So I'm going to do 2r this time instead of diameter since I'm looking for the radius, not the diameter. So what we're going to do is we're going to plug in the degrees. So I've got 100 over 360 times 2 pi r, and that's going to equal my arc length, which is 42.6. So again, I'm just plugging those numbers into the formula. So if I reduce this, I get 5 over 18 times 2 pi r equals 42.6. And so then on the top here, I'll get 10 pi r over 18 equals 42.6. And then we'll just reduce that fraction. So that's going to become 5 pi r over 9 equals 42.6. And then times 9 on each side. So I'm going to get 5 pi r equals 383.4. And then I'm going to divide by 5 pi. So then my radius will equal about 768 or 76.68 pi. So I'm not going to divide by pi. So we're just going to divide by 5 and leave the pi in our answer. So if it's in terms of pi, then it'll be 76.68 pi as our final